I have one more very short topic here to wrap up chapter 10, and it's the use of a dummy variable. And I think it's kind of interesting. To me, this is kind of a throwaway topic, but I think it's worth a quick peek. And the example the book gives is on page 432. And what they did is that they measured data from West Coast states versus East Coast states of the United States. And they calculated the difference between the average summer temperature and the average winter temperature. Alright, and so imagine California. If you take the average summer temperature and subtract the average winter temperature, you'll get a difference. And you can do that for the state of Maine or the state of Florida, East Coast states. And so they went through and collected all those and separated by West Coast and East Coast. And the analysis is based on, is there a correlation between the two coasts? I mean, it doesn't matter, is one coast different from the other? And you can actually do regression analysis on this, which is quite interesting when you think about it. Now, the West Coast tends to be more moderate in those temperature variations. I lived in Los Angeles for about a year and a half when I went to graduate school at USC. And it's like paradise out there. It's no wonder it's so crowded out there because the weather is just fantastic almost year-round. A couple of days in the summer it gets up to about 110 degrees, but being desert, as long as you're in the shade, you're still comfortable. But most of the time in the winter, the summer, the temperature is around 80 to 85 tops. In the winter, I don't even remember if it ever got down to freezing in the winter. On the East Coast, a lot different. Summers can be very hot, winters can be extremely cold, and so you have probably bigger differences. So the author plotted the data and arbitrarily assigned a value of 1 for West Coast states and a value of 0 for West Coast states and value 1 for East Coast states. And then here are the temperature differences. And here we have a couple of values here. How many? 1, 2, 3, 4, 5. They must have included more than California, Oregon, and Washington. They must have included 2 other states in the West Coast. So you had about 5 measurements here. And East Coast, you had maybe 6 states, which were up around here. So there's a scatter plot. And what's funny is that you assigned a number to each coast. Now that assigning a number to West Coast or East Coast would seem silly on the surface, but when you have just two of these, 2 possibilities, then you can do that. Now if I had West Coast, East Coast, and middle of America, Midwest or something like that, 3 of them, then I couldn't do this analysis. Because with 2 points you can connect a straight line. With 3 points it's not always a line. So this dummy variable, and these are the dummy variables, 0 and 1, only works when there are 2 dummy variables. And so you can literally calculate a regression line through those. And if there's, in this case it would be a positive slope, so positive correlation, so you could do a hypothesis test. And if that slope or correlation is significant, then there is a difference between the 2 coasts. If it wasn't so clear cut, if this line was fairly flat, close to flat, then you might say, well, there's really no difference between East Coast and West Coast. Now, a hypothesis test would probably fail to reject the null hypothesis in that case. And that's if the differences were much slighter and your line was almost flat, then probably the hypothesis test would say, fail to reject null hypothesis, no significant correlation there. But apparently there is a correlation between the states, and if you've been on both coasts as I have, you would definitely feel it. So anyway, kind of an interesting usage of variables where these are definitely not metric variables. West Coast and East Coast are not metric variables, they're categorical. But if you only have 2 of those, then you can do this dummy approach. So anyway, that's all I wanted to show about that. I don't expect you to do one of these, but I think it's kind of an interesting way to end this chapter.